right, number 13. I do have it recording. Thank you. No, that's great. Okay, so we have the different grade levels of people at the high school and then what they ordered for their side. They either got a salad or fries. From those who purchased lunch, a student is selected. What's the probability that the student selected will be in grade 10 given that they ordered French fries? So only look at the French fries row and pick the grade 10 students. What numbers are you looking at? 71 out of 248. We're only looking at French fries, grade 10 out of all the French fries. Oh, and you don't have to do anything else. It is C, very good. I always tend to overdo. Number 14. A high school theater club has 40 students. 6 are left-handed. 2 students from the club will be selected at random, 1 at a time. Listen closely, without replacement. I'm going to pull a student. I'm not going to put them back in the group before I pull the next student. What's the probability that the 2 students will both be left-handed? Now, if I'm being honest, this really goes with chapter 6, but I think you can handle it, okay? What's the probability that the first person I pull from the group will be left-handed? Okay, but I'm not putting them back in the group. So now, assuming that that person was left-handed, how many lefties are left? Yep, and there are only 39 students left. Good. And that is 30 over 1,560, which is B. That without replacement stuff is a little bit different. These really aren't independent events, but whatever, we can handle it. 15. "40% of students walk to school. 32% of students have been late at least once. 37.5% of students who walk to school have been late." That's a given. That's a conditional. Out of those who walk to school, 37.5 have been late. Think about that. 1 student is selected at random. What's the probability that the student will be walks to school and late? Walks and late. You have on your formula chart this conditional formula, and we're just going to be solving for that one. Well, let's read here because I feel like I kind of botched this a little bit in 7th period. Because we know, look at that 37.5%, hone in on that. That is given that they walk, that they've been late. So listen really closely. Given that they walk, they've been late. So I'm going to make late be my A and walk to school be my B. So now I know what to put where. So that's the 37.5 over there on the left. That's they walk to school, given they walk, that they're late. I need to figure out X. Now what will go on the bottom? Because there's a number we don't need hidden in this paragraph. Yeah, we're going to put the percent of students who walk to school because that's the given over here. So that's the 0.4. So you don't end up needing the 32%. Now mathematically you just do 37.5 times 0.4 and you get, why do I keep, yeah, 15. Oh, I mixed my, I was like, what the heck? I mixed percentages and proportions. Okay, so 0.375 times 0.4 is 0.15. And that is B. Number 16. Given independent events A and B, it tells you they are independent. Here's the probability of A. Here's the probability of B. Which of the following must be true? It looks like I've got some conditionals and I've got some unions. Well, I'm going to start with the most basic, which is if I know that events are independent, then I know that if I multiply them together, that'll give me the intersection. So the probability of A is 0.3, the probability of B is 0.5, and so the intersection must be what? But, that's not in any answer choices. Now I can use, I've already started this process, I can use this in my next part. What do you think we could do to find out which answer choice has something accurate? I mean, we could do the conditionals. Yeah, we could. All right, let's just try it then. So I'm using this thing. So A given B should be equal to 0.15 over 0.5. So A given B should equal to 0.3. Is that an answer choice? No. A given B should be 0.3. 0.3. They mixed it up on part B. The probability of B given A should be 0.5. Golly, taking us for a ride here. We know that A is out. So D and E tell me I need to find the union. So look at the formula on the left-hand side of your formula sheet. This one that we used before. Now that we know A and B in the intersection, let's do 0.3 plus 0.5 minus 0.15. And that will tell us the intersection, or excuse me, the union of A and B. Probability of A plus the probability of B minus the overlap is 0.65. That is an answer choice, that the union of A and B is 0.65. Wouldn't necessarily call that advanced, but it kind of is. 17. While investigating customer complaints, the Customer Relations Department of Sonic Air found that 15% of flights arrive early, 25% arrive on time. Additionally, 65% are overbooked, 72% are late or not overbooked. One Sonic Air flight will be selected. What's the probability the flight selected will be late and not overbooked? Oh. I'm kind of brain dead here. Let's see. Early, on time, or late. Early, on time, or late. Is this a tree diagram? I don't know. I need some insight. I need you guys to help me. Well, can you tell me why you think it's E? I have, full disclosure, I have worked this problem before. I'm just not remembering how I tackled it. Oh no, it's definitely not E, because look at the wording. It says 72% are late or not overbooked, and we're supposed to be finding that they're late and not overbooked. Okay, which says the union one? Is that what you're using? Because we're trying to find and not overbooked, so we're trying to find the intersection. We know the or overbooked is 0.72. Late, okay, what's the probability that a plane is late? How are we figuring that out? A plane is either going to be early, on time, or late. Well, early is 15%, on time is 25%. Ooh, this is an advanced problem because you have to have all of this thinking going on. Okay. Now what's the probability of overbooked? Oh, sorry. Subtracted from 1. What's the probability that a flight is overbooked? Because that's our B in this situation. Oh, good. They already have that given to us. Okay. Not as difficult as I remember. Not as difficult as I thought it was going to be. So 0.53 is the intersection. Oh God. Did I do something wrong? Oh God. Late and not overbooked. Oh. Well, hang on. Oh my gosh. This is wrong. Not overbooked is our event B. Well, 65% are overbooked. So that should be 35% are not overbooked. It helped for me to go back and label like late, not overbooked. Late, not, oh, and then I found my mistake. Okay. So 0.72 minus 0.6 minus 0.35. And I would have totally given up if that hadn't been an answer choice this time. So 0.23. B. Last one. The only class that is getting 100 on this. Okay, a hockey game has Eastern Division All-Stars, blah, blah, blah. On the Eastern Division team, there are 8 U.S.-born players, 14 Canadian-born players, and 2 European-born players. On the Western Division team, there are 12 U.S., 8 Canadian, 4 European. 1 player is selected at random from the Eastern Division team, and 1 player is selected at random from Western Division team. What's the probability that neither player will be Canadian-born? Are these independent events? So if I can just find the probability that the first team, if I pull from the first team and that person's not Canadian, I can multiply it by the probability that I pull from the second team and they're not Canadian. So I'm going to have to organize my thoughts. Eastern Division and Western Division. On the Eastern Division team, there are 8 U.S., 14 Canadian, and 2 European. So there are 24 players, and I'm looking for not Canadian. So 16 out of 24 is the probability that pull from the Eastern team, and they're not Canadian. And multiply that by the Western, which is 12 US, 8 Canadian, 4. And how many of those are not Canadian? Was that the same? Did we mess up on the first one? Oh, the first one is 10, isn't it? Because it's 8 plus 2, then not Canadian. Okay. $160 out of 576. We made it. And I honestly didn't know if I was going to make it through this problem number 17. That one's kind of a beast. I don't think there's anything on my test on Friday that's that difficult. I really don't. And that's just my opinion. And that's it.